Welcome back to EarthSky. We've got a great show for you today. We have David Kring. He's a planetary scientist, and he and his team, he's also a geologist. He and his team discovered that billions of years ago, something hit the moon and carved not one, but two Grand Canyon sized holes on the far side of the moon. So, this is an ancient structure with a brand new discovery. Welcome, David. Welcome to the show. David, researches the geological history of Earth, Moon, Mars, all the planetary, well, some of the smaller bodies, and impacts on Earth, and the effect on the environment, its role in biology, how life arose and changes, and he is a specialist in the Chicxulub crater, impact crater. And that's the one that has been linked to the Cretaceous Tertiary die off, the event that killed the dinosaurs. So, David, it is a real pleasure to have you with us today. Thank you.
Oh, my
So,
pleasure.
so you and your team discovered that a cosmic impactor, maybe an asteroid, maybe a comet, hit the moon billions of years ago. Two instant Grand Canyons on the moon. In fact, in the release that we got, you described them grazing the planet or the moon. Um, Tell us about the discovery. Tell us what you've learned about how this event unfolded. What happened? This is
Yeah,
fascinating.
yeah. So these two canyons are on the lunar far side. So in that sense, they're out of sight. So they're a
Right.
little bit mysterious, hidden from view. But we've seen them in images since the Apollo era.
Mm,
So Lunar Orbiter 4 actually captured them before the Apollo astronauts landed, but they're at the part of the moon that we weren't planning to explore then. They
mhm.
are part of the part of the moon that we're planning to explore in the near future. And so we've
Ah,
been taking a closer look at the geology of that region of the moon. And as you said, these radiate from an impact crater. We call it the Schrodinger impact basin. And
Schrodinger.
I should
Yeah,
explain that terminology. That when
please.
we say impact basin, we're referring to a very large crater. So
Yes.
on the moon, when a crater is 300 kilometers or larger in size, we quit calling it a crater and we start calling it a basin. And
So
so
this thing
it's a
is
monster.
immense. Wow.
It's
Okay. Sorry.
320 kilometers across. And what we've deduced is an asteroid or comet, roughly 25 kilometers in diameter, flew over
Okay.
the South Pole and then hit the far side of the moon. And in the process of excavating that large impact basin, it threw up a curtain of debris. Within that curtain of debris were some streams of concentrated rock. And all of that material ends up crashing back down on the lunar surface outside the rim of the crater. And in
Uh-huh.
this case, those two streams of rock hit the surface, just boom, 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 in this long chain of collisions, which themselves were like small explosions. They
So
each one of them created a crater 1,000 times bigger than Meteor Crater in Arizona, and then
wow.
collectively, then they excavated these two large canyons.
That's insane. So essentially, what the image that you're giving me is a rock skipping across the surface of a pond, right? It's got a lot of momentum. It's chaotically spinning along and hitting the lunar surface like it was water and bouncing along. Is that
No,
is that
no,
essentially the case,
no,
or
no, no, not
no?
at all.
Darn.
So, no.
Darn.
So in fact,
Okay.
the asteroid would have penetrated to a depth about its diameter, so about 25 kilometers. And there, the kinetic energy is released
Wow.
explosively. And so the
Uh-huh.
material, as it gets excavated, it gets blowing upwards. And then that material goes arching over the lunar surface.
Ah,
And
okay.
so it goes actually quite high. and then it comes falling back down, and it gets launched. To give you an idea, it gets launched from the crater in speeds in excess of 2,000 miles per hour.
Wow. Okay, so it's really moving,
It's
and
flying.
I assume it's a liquid magma at that point. I don't know. Is it still solid or is it in a liquid?
Some of the material is solid, some is liquid, so it's a mixture.
Okay. And so where did it come from? Whatever hit the moon, do you know what direction it came in? It sounds like you know how it arrived. What do we know about it? What do we know about
Yeah,
this thing?
we don't know if it's an asteroid or comet at this point in time, but and to answer that question, we'll need to land on the moon and collect a sample and bring it back, and then we'll be able to tell if it was an asteroid or a comet. But until then,
Okay.
we just have to say it was either an asteroid or comet. Now, I should explain that most impact events are produced by asteroids.
Hmm.
More than 85% or greater are produced by asteroids. So, you know, in general, asteroids are responsible, but anytime you're referring to a single impact event, it's uncertain. So
Right.
this asteroid or comet hit the lunar surface, and then it excavated a huge volume of rock from the lunar crust down to depths. Oh, I'm going to forget the number, but it's in excess of 20 kilometers. Material was excavated.
So about the same size as the impactor, I think is what you said earlier, right?
Well, that's how far it would penetrate the crust of the moon.
All right. Okay. Okay. So you can tell the difference between a direct hit and a glancing blow then. Uh,
Sometimes, I mean, so I should explain that the most probable impact angle is 45 degrees. And so,
Makes sense.
depending on your definition, that's oblique or not. And that's just simply orbital dynamics. Okay,
Right.
that an impact event at that angle will oftentimes generate a circular crater. There's nothing about the crater that tells you it was 45 degrees versus vertical. But
Okay.
in this case, we have debris thrown out around the crater that is preferentially deposited in one direction. And
Okay.
so that's what's telling us what the direction is. And it also implies the impact angle was a little bit less than 45 degrees.
So how much energy are we talking about? I suppose you would measure this in megajoules or megatons, like nuclear thermonuclear blasts.
Yeah,
How
yeah,
much energy?
yeah. The megatonnage is huge, and I don't have the MT number off the top of my head, but what
Mhm.
I can say is the energy to produce these two Grand Canyons on the lunar surface was equivalent to 130 times the energy in the world's entire inventory of nuclear weapons.
Oh my, that is quite an energetic
Yeah.
event. You don't see things like that well, actually you do if you look at the sun, but you don't see it on a planetary body that often. So these are not usual. This is a rare event that happened. Or is it? Tell us about that. Is this a
Yeah.
rare event? Have we seen more of these?
It's not the type of event that we are likely to see very often now. It is
Good.
a very common event, however, early in solar system history. And
Mhm.
so the Schrodinger impact event was one of the last of the great
Oh,
basin forming events on the lunar surface. And during the first 3, 4, 500 million years of solar system history, all of the terrestrial planets or planetary bodies, like the moon, were getting clobbered.
right.
So at that point in time, impact events of this size and much larger were common.
Were common, but not anymore. They're not common now. But then we've got Chicxulub, which happens 65, 66 million years ago, somewhere in that range, and killed all the dinosaurs, allowed mammals to become the dominant animal on the planet. Could something like this happen again? Could something of this size hit Earth? Is this a danger to us now?
Well, yes. I mean, impact cratering
Ooh.
is an ongoing process.
Uh-huh.
So the Earth is going to continue to get hit, and we see it getting hit virtually every day with
True.
micrometeoritic and meteoritic size debris. The Chicxulub size impact event is the type of impact event that occurs on average
Okay.
about once every 100 million years. Um,
Hmm.
at the moment, we do not see any asteroids of that size, and we're talking, in the case of Chicxulub, 12, 14, 17 kilometers in diameter. We don't see any objects of that size on collision courses with the Earth in the foreseeable future. But we do certainly have to worry about the more frequent, smaller impact events. Things on the order of 300 meters to a kilometer in size would be, it would cause global consequences. And even a small 30, 40, 50, 60-meter object like the one that
Hmm.
produced Meteor Crater could
Right.
completely destroy an American city.
Oh, easily. The one that exploded over Tunguska, or the one that produces Meteor Crater or Beringer Crater,
Yeah.
if you prefer. Okay, so the next question I get, I have a couple ways we can go here, but let's talk about something you already mentioned. A sample would tell us what this object was. And we're going to go to Schrodinger Basin as part of the Artemis program. That's the lunar landing site that we've got picked. So, what does this mean for Artemis? Does this how does this affect our plan to go back to the moon? That's the question.
Yeah. Okay. So there's a couple of issues with that question that I should address. So first of all, Schrodinger is a very high priority science destination.
Hmm.
And in fact, a robotic mission is scheduled to land there next year.
Cool.
It is designed to carry some geophysical instruments. It will not be collecting the sample, will not be bringing sample back, but
No.
it will initiate the exploration of the Schrodinger Basin. But the Schrodinger Basin itself is just outside the initial Artemis exploration zone,
Okay.
which extends from the pole, the South Pole, to 6 degrees latitude north.
Okay. That's
Okay,
a big area.
it's a
All
big
right.
area. Um, so the issue with Schrodinger's impact, however, was whether the debris produced by that covered the Artemis exploration zone. And because we were able to determine the trajectory of the impacting asteroid and therefore the trajectory of the debris ejected, we were able to show that very little Schrodinger debris landed in the South Polar region. And that's
Huh.
important because although we would like the astronauts to eventually collect a sample of Schrodinger, um, because the South Pole is not buried by that, the astronauts can collect even older material. And so we'll
Oh,
be able to look even farther back in Earth lunar history.
okay. And so, what do you hope to learn from the samples that someday you'll get back? What are you looking at, and how does that relate to your larger research about the evolution of the planets? What are
Yeah,
we learning here?
great question. And I guess I want to preface that my answer with the following observation, and
Mm.
that is all of the big ideas that we have about the Earth Moon system, about lunar evolution, come from samples. So when we speak about the giant impact hypothesis for the Earth Moon system, that
Mhm.
comes from chemical analyses of samples an astronaut collected and brought back to Earth. When we
Right.
talk about the moon may have at one point in time been surrounded by an ocean of magma, that comes from a
Wow.
sample an astronaut collected and brought back to Earth. And so samples are just these gold mines of information. And so when we speak about transformative science, what we basically require is the collection and return to Earth of samples for analysis. And so, having said all of that, let me get to your question. So,
Sure.
we have this idea that the Earth Moon system was produced by the collision of the proto Earth and another planet about half its size.
Right.
If we collect samples from the oldest region of the moon, we should
Ah,
have the chemical and isotopic fingerprints to test that model. I spoke a minute ago about the lunar magma ocean hypothesis. We have a
right.
few samples from the near side equatorial region where the astronauts landed during Apollo, but there's huge uncertainties in that model that a sample or samples from the South Pole can address. Schrodinger's, as I said before, that at the tail end of this early period of bombardment, we're
Uh-huh.
very keen to understand the magnitude and the duration of that bombardment. That is the cadence of the impact events and what caused them. And so if we actually collect samples from some of these large impact basins like Schrodinger, bring them back, we can determine the age and we can determine what type of object produced them. And just
Wow.
go on and on and on. But so these are the
There's
types of things that we hope to get out of Artemis.
so much to learn, so much to know, and it's just sitting there. It's so close. It's just right there. Just got to go get it. Okay, so we're getting some questions from the audience. And the first one is, what would it be like if future explorers went to the moon's Grand Canyons? Would they be likely to walk down the canyon, drive a rover? And does David Kring think astronauts will someday do that? Any way to predict when that might happen? So you got to put
Okay.
on your
Yeah.
speculation goggles, I guess.
So I think it would be relatively straightforward to astronauts to land on the rim of the canyons. And in fact, we had an artistic rendering of two
Mhm.
astronauts on the rim of one of the canyons published with this article. And and that would be well, the views would be extraordinary. Okay,
No
so
kidding.
anybody who's been on the rim of the Grand Canyon and looked into the Grand Canyon, imagine looking into a canyon that's a kilometer deeper than the Grand Canyon. I mean,
Mercy,
it
my,
just
that's
would
amazing.
be, yeah, awesome. Okay,
Oh,
but
yeah,
but
okay.
the astronauts are not there for a sightseeing tour.
No,
They're
they're the
serious scientific
scientists.
explorers, right?
Hopefully, they're gonna send geologists this time. They didn't
Yeah,
send enough geologists
yeah.
last time. Anyway.
So on the rim of the canyons, they actually will have an opportunity of collecting samples that were excavated from the bottom of the canyon. So 2.7 to 3.5 kilometers beneath the surface. They don't have to go into the canyon. They don't have to try to climb down the walls of the canyon to get those samples.
Mm-mm.
The impact process that excavated the canyons very kindly deposited all that material on the rim. And so it's just waiting there for the well-trained astronaut to collect.
So you just pick it up and take it. This would, I assume, be some of the oldest material available on the lunar surface. Is that correct?
Some of it would,
Yeah.
and I don't want to say it is in some sense just waiting, but
Yes.
but
No, but
it
it'll have to
takes
be.
a well-trained astronaut to know what sample to pick up. I mean,
Mm,
there's gigatons of material that's been thrown up by these impact
yeah.
events, and so it has to be a well-trained astronaut to differentiate the best sample from all of that debris.
Okay. So we got to send people who know what they're doing. Maybe some of you, your students, maybe you want to go to the moon, David? Would you like to go to the moon?
I would love to.
I would
Yeah,
love to as
yeah.
well. Okay. So I want to go off completely off in a strange direction to settle or to look at a controversy. Is the moon a planet or not? Yeah, are
Well,
we living in a binary planet system or is it just a satellite?
it's. I call it a planetary body. It's the
Mhm,
Earth's moon. It from the Apollo analyses, it seems to be debris, largely um, generated or extracted from the proto-Earth,
mhm.
with a little bit of material from an impacting object. But
Right.
uh, in my mind, yeah, the Earth and the Moon go together.
Mhm.
They've been together since that giant impact event, or the
Right.
putative or the hypothesized giant impact event. And but no, I wouldn't call it a binary.
Okay, cool. I'm always interested in that question. Um, so back to the Grand Canyons on the far side of the lunar surface. Someday regular people like me, we may go up there. If we went down into one of those, we wouldn't see strata like we would in the Grand Canyon, would we? We would see something. What would it look like inside that? I mean, people are going to want to go just like people want to go to the top of Mount Everest.
Yeah. So it depends on where you're looking in the canyons and what portions of the canyon walls. In some
Okay.
areas, it likely will be layered. They're not. They're not what they're not going to be layers of ocean sediments. They're going to be
Mhm.
layers of impact debris from a variety of
Oh,
craters. And so
wow.
the upper lunar crust is composed of layer upon layer upon layer of impact ejecta blankets.
Mhm.
Um, Now, at some depth, you also will have magmatic intrusion. So people may be familiar with the granites of the Black Hills. So
Right. Yes.
that's an intrusion. It's been
Okay.
exposed at the Earth's surface. And so
Mhm.
intrusions of that type could also be exposed in
Oh,
the canyon walls or in uh, the Schrodinger Basin itself. The Schrodinger Basin, if I can lead you back to the basin,
please,
it
please
has
do.
it has a peak ring which is mountainous in scale. So that this peak
Oh,
ring rises 1 to 2.5 kilometers above the basin floor. That's Rocky Mountain in scale.
it
Okay,
is.
and we can tell from the Lunar Reconnaissance Orbiter that it has rocks in it that were uplifted from 20 to 25 kilometers beneath the surface. And all of those are magmatic rocks that were intruded into the crust of the moon.
Oh, wow. We're gonna learn so much when we finally get there. Wow. Which brings me to, you know, a little closing question here for you. What is your next move on Schrodinger at the Schrodinger Basin rather? Where's the research and learning go from here? You and your team, what are you finding? What are we doing?
Yeah, well, we will continue to model this impact event, and each model will become more sophisticated. In fact, we have a student who is now going to focus on this particular impact basin as her part of her PhD thesis.
Mm.
We'll also continue to look at landing sites and
Oh,
design traverses for both robotic assets and human assets in and around Schrödinger and elsewhere in the South Polar region.
now I look forward to talking to you again in the future when some of this has come to pass. This is fascinating stuff, David. I thank you so much for being here and giving of your time to explain what's going on the moon. Oh, and thank you guys for tuning in. We'll be back. I'll be back on Monday with Jonathan McDowell, who is a space historian. We're going to talk about Starlinks falling out of the sky and his space archive. I'd also like to thank Natalia, who produced for us today, and Deborah Bird, our founder at EarthSky, who is backstage talking in the chat. Thanks, folks. Appreciate your time and your attention. It means a lot to me. Remember, it's one Earth, one sky, EarthSky. See you soon.